Let's find out the difference between artificial intelligence, machine learning, and deep learning. Well, machine learning is a subset of artificial intelligence, and within the subset of machine learning, we have deep learning. Now, there are four types of machine learning algorithms: supervised, unsupervised, semi-supervised, and reinforcement learning. In supervised learning, we have regression and classification. So the example of regression would be we have some data of bedrooms and area, living room, and with that we find out the cost. So the cost value can be numerical or alphabetical or anything. So these type of value where we get numerical values is called regression. And in case we just find some binary or classification values like yes, no, or true or false, something like that, then those problems are called classified supervised machine learning algorithm. And under unsupervised algorithm, we have clustering, dimensionality reduction, anomaly detection, and association. So in clustering, what we have is we plot we plot the data in a graph, and we see that this data is forming some clusters. Like here, we can see three clusters are formed. Um, and from this cluster, we can segregate data, and we can tell that okay, this if we get a point close to this, we can say that this point also belongs to this green classification, categorical classification. So this is called unsupervised ML. Here we are not getting any output, we are just getting clustered. And then dimensional reduction. Suppose we have data of size of bedroom and size of living room. But if we have two columns of such data, then it's redundant. So instead, what we can do is we can merge this data column into one. We can say like total area. With this, we can get a single column of data. And this helps in column reduction, so it's better for ML algorithms. Now, anomaly detection. Here we have a graph, and we see the graph is going normal here like this, but here we see a spike. Now this is an anomaly. So by this algorithm we can detect the outliers. Another thing could be we plot the data in a scatter plot, and then we see that we see another point which is away from the cluster. So this is also an anomaly. And then we have association. Here we learn the correlation based on data. Now in association, we basically see that um, the correlation based on data. I mean, we have data and we try to find out the correlation of the data, and from there we try to associate what are the changes and what not, and from there it's called association learning. Now come to semi-supervised learning. Semi-supervised learning. So semi-supervised learning. In semi-supervised learning, as the name suggests, we use both supervised and unsupervised learning. We label only few data, and then the algorithm automatically detects the other labeled data. Like with supervised learning, we can find some data points and labels, and from those data labels, we can find out that what are the other unlabeled data. Like suppose you have a gallery in your iPhone app, a picture app. There you click on the pictures of people, and you see your pictures. Okay, profile. You click on your picture, and iPhone just automatically shows you other pictures of you. So that is how semi-supervised learning works. Now, reinforcement learning. Suppose an algorithm, let's say here in case it's a cat. Now, if the cat goes to the bucket of water, he loses minus 150 points. And if he goes to the fish, he gets 50 points by getting the fish and he feeds himself. Similarly, in this algorithm, the cat will all try to choose fish every time because it gives him more point. But in case of choosing the water, it deducts points. So we increase the points and deduct points in the ML algorithm. That is called reinforcement learning. Now let's learn about batch learning. What is batch learning? So we take the data and we train it in an ML model and we test it locally and then we deploy it in a server. That is called batch learning. because we are training the model and making the model in our local setup and then putting it in a deployment server. So disadvantages are too much data. If it's too much data, then it is very time consuming, and hardware, because if we are processing the data in our local machine, then we have some hardware limitation. And availability, not every time we can get the data from server. Suppose you are doing a military project where there is no network tower, so how can you get the data from the server on from the cloud? Or maybe you need, or maybe in satellite communication, like satellite connectivity is not there, how will the satellite get the data if we don't connect to the tower? In that case, that this type of batch learning is not possible. So here we have this called online learning. In online learning, we have the data, we train it to ML model, and then we test locally, and then we deploy it in the server. Now the ML model is also deployed in the server. Now the data is given to this ML model, which is inside the server, and it trains and then gives out output within the server itself. This is called online ML. So I will say why online ML is better than batch learning, because concept drift. Like if the nature of problem is volatile, we use online learning because sometimes there is some problem and it changes rapidly. So we call it volatile problem. And in that case, we need to do online learning because the change is too much for us to take the data and train it locally. So it's better to process it online. So that is called concept drift. Now, cost effectiveness. Since online learning problems are solved in individual, hence it's cost effective. Like um, all the in batch learning, what we do is we put every data in locally. But here in online learning, only the chunk of data that gets into the fits in the model of the AI inside the server gets processed. So it's cost effective. We are not processing every data. We are processing what is required. And faster solution. Here problems are divided for individual chunks of data, hence faster solution. Like all the problems are like solved in using chunks of data. So the solutions are generally faster. Now let's see what is learning rate. If learning rate is basically the rate at which the algorithm learns. Now, if the learning rate is too fast, then the algorithm does not remember past and malfunctions. Suppose we train the algorithm in such a way that the rate is so fast that it learns very fastly, but it does not remembers past and it malfunctions. Similarly, if learning is is very slow, then it difficult for the algorithm to give correct output and correct data. And similarly, if the learning rate is slow, then for the correct data, the it will give incorrect answer. Outcore learning. Let's see what is this. In outcore learning, basically what we do is, in generally what we do ML problem, we just do a big chunk of problem and solve using algorithms. But here what we do, we divide it in small sub problems of other ML, like chunks of ML problems, and from there we get the data and we make a model and then we put it in the server. This is called out of code learning. This is tricky and very risky. So here is the difference between batch learning and online learning. Batch learning is basically offline learning. So it is less complex as model is constant, and dynamic complexity in online learning, the dynamic complexity as models keeps evolving over time. Now come to computational power of batch learning has fewer computations, single time based and training, while online training has continuous data ingestion result in consequent model refinement computations. While offline learning is easy to implement in production, but in online learning, it's difficult to implement and manage. Applications of batch learning, image classification, or anything related to machine learning where data patterns remains constant without sudden concept drifts. And in online learning used in finance, economics, health, where new data patterns are constantly emerging. Perfect usage for online learning. Tools, industry proven tools like Scikit-learn, TensorFlow, Keras, Spice, but here for online learning tools are active research, new project tools, example MOA, Samoa, Multiflow, Multistream DM. Now let's come to learning. Two types of learning are there. What is instance based, where we memorize, and another is model based, generalizing. In instance based, we have, suppose we have data like parameter A and parameter B, and we have parameter C. Now we plot this in a graph and we see that this blue points are forming one chunk and these red points are forming one chunk. Now what we see is we take one random point over here. Now we go to certain distance, let the distance be k. Now we check in this radius what are the maximum types of points are there. Is it the blue points or the red points? Whatever points is the greater in number, then the random chosen point should also belong to that color category. And this algorithm is called k nearest algorithm, KNN. Now let's come to model based learning. Here we are generalizing. Instead of searching for whether this point belongs to this area or not, what we do is we generate a mathematical solution to a curve. Like we are doing a mathematical equation of a curve, and we check whether the data point lies beneath this curve or outside this curve. Example would be linear regression, logistic regression, decision trees. Okay, let's see the difference between a conventional. Let's see the difference between conventional machine learning, instance-based machine learning. Like conventional is basically model-based. So conventional model-based, prepare the data for model training. In instance-based, prepare the data for model training. No difference there. Train model from mining training data to estimate model parameters. Example, discover patterns. Okay, in conventional machine learning, uh, we try to get patterns like this equation over here. But here we do not train the model. Pattern discovery postponed until score received. We just calculate the score over here, nothing else. Then we store the model in suitable form. There is no model to store here. In instance-based learning, we are not storing any model. We are just trying to find out what is the nearest element in the nearest. What are the nearest points in the vicinity of the chosen random point. Now generalize the rules in form of model given before scoring no generation before scoring, only generalize for each scoring individually, and then see. Predict unseen scoring instance using model. Predict unseen scoring instance using training data directly. Like from training data itself we can get the prediction. But here we are doing training the ML model to find out the curve. Can throw away input training data for the model. Must be given requires unknown model form, may not have explicit model form. Storing models generally requires less storage. Here, storing training data generally requires more storage. In instance-based learning, we are literally storing the whole data, so it will take more storage, obviously. But in case storing models in a conventional machine learning, where we get the equation of curve, what we are doing, we are basically storing some variables just to store some uh, curves equation. So like this is not something which will take a lot of time to lot of storage to store. Now coming to challenges in ML data collection. Well, data collection is very challenging because you don't know how to find data. Like people have to volunteer or you have to pay somewhere something to get the data. Second is insufficient data or level data. Sometimes data can be very not leveled correctly, and data must be very less. It's if it's very less data, then it's not going to perform. The model is not going to perform. Suppose we have data set A and data set B, but data set B is 10 to the power 9, whereas data set A is only 10 to the power 2. We obviously B will perform better because there's a theory called unreasonable effectiveness of data, where basically the more the amount of data is, the model performs better. Now let's see non-representational data. Like suppose we get some points and then we got the regression line from the data. But suppose the data was collected only for certain points, but and For these points, the data were not collected, so this data is not represented. So data collection is very important, and if some data is not represented, then also it's very problematic because this data is not present. Then we have poor quality of data. Need to clean the data. Like there are some garbage things in the data, so we need to clean it using some techniques. Independent features. Suppose age, height, and location. Here we are training some data. We are training a model to check whether the candidate can be suitable for swimming or not. But here location is an irrelevant feature. We don't need, because location is not how you swim is independent of location. So that's why location is irrelevant. So we combine the columns and then we do it in these columns like age, height, and weight. We can combine it into a single column, and this process is called feature engineering. It's a very good field to pursue. Now what we have is overfitting. Suppose we get the data points of like this. Now um, and we see the curve is almost, this red line curve is almost similar to the blue line curve. This is called overfitting because it's perfectly fitted model. And second, let's see underfitting. Here these are the points, but the regression line comes out to be like this. This is underfitting because you see there are many of the points which are not lying to the line. Now let's see software integration. It's difficult to integrate in real world product. Like if any ML model is there, it's very difficult to integrate in real life problem. Offline learning deployment, difficult to deploy on expensive cloud storage. Deployments becomes very costly because it depends on cloud storage. Cost involved. ML ops, DevOps are needed to maintain and deploy the application and make sure that the application runs effectively and safely and efficiently. Now, applications of ML we have in retail, like in big billion days sales. How does the company get the data to? How does the company know that uh, if we purchase this amount of iPhones, then this amount of iPhones might be sold this year? So with this big data, they are able to buy number of devices at chunks with a wholesale price, and they can clear their inventory very quickly in big billion days or something like that. So that's one application. Another is in retail, like in Big Bazaar, Vishal, Megamart, in this type of Walmart, in this type of shopping where the placement of products become very important. Here, certain products are placed in certain way so that the customer has maximum rate of buying. So these depend, and the way these are arranged are based on data of customer collected over many years. Whenever you go to this type of stores, they collect your phone number and they get your data that what type of things you are buying. And they have basically a public profile, not public, they have your personal profile of what type of customer you are, what type of things you buy, and based on that what average people also buy, the algorithm knows, and based on that these products are arranged in these shopping shelves so that people buy the maximum stuff. Another thing is banking and finance. Here, whenever you apply for credit card, they check you by a civil score, whether you are a good per candidate to be given based on previous data, like all your previous transaction through your credit card or whatever loans transaction. These are processed in your they have a they have a uh, personal profile of yours where they know that through your PAN card, that they know that what kind of person you are, what kind of spending you do, and whether you do the billings on time or not. From there we get the civil score, and based on that civil score you get credit cards or loans approved. Another thing would be in which location or place we can set up bank so that the profitability becomes maximum. This type of data can also be analyzed with ML algorithms, and then perfect locations could be found out for maximum churn. Now we have transport. You see when you book buses through these apps, so this apps have dynamic pricing based on demand. Their uh, prices increase or decrease, even in flights also. So it's becomes very beneficial. It's very becomes very profitable for the companies operating these ML algorithms, such as air buses and airplanes. Similarly, in Uber Drive, you can see that whenever, suppose, let's talk in driver's point of view. So when a driver is trying to find out where is the best place to go so that they can pick up maximum number of customers. So the algorithm basically tells them to go to certain location in map, and the driver goes there and picks up many of the successful customers. So it's good for the customers and also the drivers because they earn more money while doing this. Now is manufacturing. It's called predictive maintenance is the one thing that is happening in manufacturing. Is in many car manufacturing or any big electrical machines manufacturing, we have this type of robots, mechanical robots. So we have to do maintenance of this robot. So we don't wait for the robots to fail and uh, solve the problem. We do it proactively. What we can do is monitor every movements of the machine's parts, whether it's become slow or fast too much. Then from that data, we can make a model and predict whether the machine is going to be failing or not. And before failing, we can intervene and we can supply the support technician, support engineers for this machine, and they can fix it before any bad thing happens or failure happens. Now we have consumer internet, um, Twitters, for example. There was one API called Twitter Sentiment Analysis where people used to analyze sentiment from Twitter, and based on that, we can predict stock market prices because stock market price, if we are day trading, depends on heavily on market's emotions. Like if a certain company's emotions is very low, then very bad reputation happen to that company, then the prices will also go low. Similarly, if something good news happens to the company, then the prices will also go up. So we can do consumer internet analysis with the help of ML algorithms. Now let's see what is machinery development life cycle, MLDLC. So in MLDLC, what we do is frame the problem. We get the overall mental idea, then we gather data. The data could be gathered using CSV file or API or through web scraping, or we can get the data from a database and data warehousing. Like we get the data using ETL tools, then we make the copy of a data. This process is called data warehousing, or we will use big data technologies like Spark. Now let's see data processing. In data processing, remove the duplicates, remove missing values, remove outliers, and then we need to scale the data. That's how data pre-processing works. Exploratory data analysis includes visualization, univariate and bivariate analysis, outlier detection, handle imbalance, feature engineering and selection, model training, evaluation, and selection. It's called ensemble learning. What is this is called amalgates, like it amalgates ML algorithm, multiple type of ML algorithm into one to make a much more productive ML algorithm. Number seven is model deployment. So model is deployed and this is made into a binary file. Then it is made into an API. So from the client, we make a Python app, and this Python app will call the API. This API could be stored in Heroku, AWS, GPS, anything. And this we're gonna get a gist. We're gonna give we're gonna send some information to the API, and then it's gonna give us JSON input. But we have the prediction from the binary file itself. Now we have testing, A/B testing. A/B testing is basically we don't we don't test to everyone. Like certain users get certain benefits before. That is called A/B testing, like testing in production. Optimize. L model we can optimize L model by using backup data, local load balancing, and then retrain. If you don't retrain, then it will start rotting. So ML models, if you don't retrain, it starts rotting. Now just to dive into two small concepts. What is OLTP? Means online transaction pricing. And from this OLTP, this is basically a database. From OLTP, we need to convert it to OLAP. That is called data by the process of data warehousing. And we get this data warehousing, we get the online analytical pricing. So from here, we you in this OLAP, we apply the ML models.